In this tutorial, we are going to learn about what is an equilibrium reaction. So when we first learn about equilibrium reaction, we are always presented with this generic chemical equation. We first know that it is an equilibrium reaction by seeing this double arrow. This double arrow tells us that the reaction can go forward and it can go backward or reverse direction. So by this double arrow, we understand that it can go both ways and there will be something remaining for all the chemical species at the end of the chemical reaction. So ultimately, the concentration of all the chemicals will remain unchanged and it will go flat. Now, one thing I want to emphasize at the very beginning of the tutorial is the concept of equilibrium. When we say a reaction is an equilibrium reaction, we are saying that the rate of the reaction of going forward will eventually be the same as the rate of the reaction going backward. This is what we mean by an equilibrium reaction. But a lot of people, they get confused with the word equilibrium. They think that it is the concentration of some chemicals being the same so that they are at equilibrium. This is not true. So remember, when we say there's an equilibrium reaction, it means that the rate of going forward will be the same as the reaction rate of going backward or in reverse direction. So keep that in mind. So after we present this generic chemical equation, most teachers would tell you that to express a chemical equilibrium, we will have a big capital K with a subscript C that stands for concentration. And that means in the equilibrium expression right here, we are going to use concentration to express our chemical quantities. And most teachers would tell you this, that it is going to be the products over the reactants. And whenever you see a coefficient, it is going to be the exponents of the chemicals, of the concentration of the chemicals. So this is why we have this equilibrium expression. Okay? So make sure you understand that when we write an equilibrium expression, it is always going to be product over the reactant. The coefficients are going to be the exponents of the concentrations. Now, a couple of things that I want to focus here. These brackets means that these quantities are expressed in concentration, and the unit for this concentration is molarity. So we have to take a deep look to see what can we write on the equilibrium expression. Since it is a quantity of concentration in molarity, that means it has to be a solution. A solution is made of two things, a solute and a solvent. So it works perfectly in aqueous solution and gases because aqueous solution is composed of a solute dissolved in water. Gases, like the atmosphere right here, it is always a mixture of gases. So they are well qualified to be known as a solution. But when we have solids and liquid, while they are just pure substances, nothing is being dissolved in the solid or liquid. So we cannot say that they are solutions, and therefore they cannot be expressed in concentrations or in molarity. Therefore, we would never ever put solid and liquid in the equilibrium expression. We will only put down the concentration of the aqueous solution and the gases. So this is the reason why we ignore any solid and liquid. And with this said, it is extremely important that when you write a chemical equation, you have to put down the state symbols, solid, liquid, gas, or aqueous solution for every single chemical, so that people look at this reaction and they know which one to be included in the equilibrium expression and which one cannot be included in the equilibrium expression. All right, now You are told that this is the equilibrium expression. This is the equilibrium constant. So where does this come from? This sounds like coming out from nowhere. So we are now going to take a deeper look on where we get this equilibrium expression. So we are going to talk about a reaction, which is